until 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7, and then I'm only going to shade between those 2 points. So the integral from 3 to 7 of dh dt dt is going to be the area of the space under the dh dt graph between 3 and 7. Now, what shape did we make? Okay, that is a rectangle. How do you find the area of a rectangle? Okay, so what's my length? 3 to 7 is how long? 4. What's my height? 2. 4 times 2 is 8. Now, we're going to back it up for a second. Before we put 8, let's put units in. Okay, across the x-axis, what is 4 measured in? So 4 years times, and then what's the height measured in? Feet per year.
So we have to write the units.
And this is for the interpret. So it'd be 4 times 2, which is 8, we said, but now think about what your units would be. Okay, remember when I take a derivative, feet per year turns to feet per year squared. Okay, what's going to happen here, though, if one of my years is on top and one's on bottom, because I did length times width? They cancel. What's left over? Only feet. Okay, so it's kind of like the opposite of what happens for a derivative. If I took a derivative, I'd divide by feet, I'd get feet per year squared. That'd be kind of like acceleration. But when you do an antiderivative, you get the units that were originally on the top. Now, let's do the interpret. So, over time 3 years to time 7 years, trees' heights increased 8 feet. Okay, now think about if that makes sense. Okay, I was measuring feet per year. I integrated and got feet. We know it's an increase because the 8 was positive. Can integrals also come out to be negative? Is that possible? Okay, that would represent a decrease in whatever you are measuring. Okay? So let's do the next one. Look at it. It says, suppose df dt represents the rate that temperature is changing on a certain day, where degrees is measured in Fahrenheit, time is measured in hours, 0 to 24. Okay, let's draw our graph. This is df dt. What is that the same as? F prime. Very good. Fahrenheit prime. It's the change in degrees. Now, it says it's measured in degrees Fahrenheit and hours, so that'd be degrees Fahrenheit per hour. What's going to go on the x-axis? Time, and time is measured in hours this time. Okay, now let's sketch a graph of our function. So it's a half f plus 40. This is linear. Think about y equals mx plus b. Where does it start on the y-axis? What's my b? Okay, 40. And then from 40, 1/2 is a positive slope, so it's going to go up 1 over 2, up 1 over 2. So just make your graph go up like that. Okay, now, where are we integrating from for us to shade? Look at your integral. 0 till 12. Now, you could rise over run 12 times, okay, but it's easier to just plug 12 in. So, let's say 12 is here. I'm going to just plug in 12 to this to know how high it would be. What's half of 12? 6. And then what's 6 plus 40? So this is 12, 46. That's your ordered pair. And now we're ready to shade. Remember, we're shading under the graph from 0 until 12. Okay, so we should recognize hopefully that shape by now. What shape is that? Trapezoid. Very good. So I'm going to rewrite my integral 0 to 12 dh dt equals, and then I'm going to find the area of that trapezoid. Now remember, your bases have to run parallel to each other. So this is one base, this is the other base. How tall are my two bases? 40 here and 46 here. So 1/2 40 plus 46. And then where will I find my height? Very good, the x-axis. So from here to here, that's your height, which is 12. Okay? What's 40 plus 46? 86. Okay, I'm going to do 86 times 1/2, and then times by 12. It comes out to be 516. Okay? All right, now, we do have to put the units. Thank you. If this is in hours, and this is in degrees Fahrenheit per hour, and I multiply those together, what's going to happen to your hours? They're going to do what? Cancel out. What's going to be left over? Degrees Fahrenheit, okay?
Do we only put the units at the end?
You can just put them at the end. We did them up here to show it crossing out, but if you can just realize they cross out, that's good enough. Okay, now let's interpret this, even though 516 doesn't really make sense unless you're like, I don't know, on the sun. Okay, just pretend. So we would say over time 0 to time 12 hours, the temperature increased 516 degrees Fahrenheit. Okay? So everybody died and the world exploded. Okay? But over 0 to 12, the temperature increased the area number of degrees. Okay? So we're going to kind of broaden this before we go back to position, velocity, and acceleration. Look at your little thing here. Okay, it says if dq dt represents the rate that a quantity is changing, then the integral is going to represent the amount that q has increased or decreased over the time from A to B. So this is what I mean by that. Let's say that you're integrating, I'm going to give you like 3 examples just for fun. Let's say it's cars per minute passing through an intersection. What would your units be after you integrate it? A number of cars. Very good. Okay, let's say that you're talking about a factory, okay? And the factory tells you how many units they produce per day, and you were to integrate. What would be left over? The number of units that they produced over whatever time you integrated. Okay, so that bottom unit is going to cross out because area, you're doing length times width, and they eliminate each other. Okay? So now we're going to do it for velocity. So take a look at this next example. If I was going to integrate velocity, which is in meters per second, what would I get? What would be left over after the seconds cross out? The number of meters that the particle or the bus or whatever it is traveled. Okay? So that bottom unit is always going to cross out, and whatever you're left over with, that's what your units will be for the integral. Okay? So integral 0 to 4. Okay, where am I going to shade on my graph for 0 to 4? Above or below? Okay, below. Now, this is the first one we've done today where it's been negative. So remember, your area is not negative, but your integral will equal negative whatever that area is. So what is your area for that triangle? 1/2 base times height. What's my base? 4. What's my height? 2. 4 times 2 is 8. Cut it in half. -4. Now, once again, why is it negative? Because the area is below. Okay? Then it says to consider the units. So if this is in meters per second and I times by seconds, what's left over? Meters. Now, we are going to interpret, we're not going to do every single one of these, but just to practice it, we're going to interpret what that means. So this is what you have put. What is my ending time? look at your integral. Okay, at time t equals 4 seconds. Okay, and then we're talking about a squirrel. So this squirrel traveled 4 meters to the left. Okay? Okay, now think about if that makes sense. So he traveled 4 units, and then the negative tells me which direction he went, because it says he's running on a power line. So he's running on a line this way. So we know he was going to the left because his integral came out to be negative. Okay, now let's go from 4 to 10. Okay, so I'm going to shade in with a different color here. 4 is here, 10 is here. What shape is that? Don't break it up. All together, it's already one shape. It's a trapezoid. So 1/2 base plus base times height. How long is my top base? 2. And then my bottom base from 4 to 10, that's a difference of 6. What's my height? 2. So I do 2 plus 6 is 8, times 2 is 16, cut it in half, we're back at 8. But notice this time, it's a positive 8. Okay? So let's interpret our integral. So we would say over time 4 to time 10 seconds, the squirrel traveled 8 meters to the right. Okay, now think about if that makes sense. I integrated 4 to 10, that's the times I'm looking at. Okay, and then the 8 meters is how far it went, but the to the right comes from the fact that my area was above the x-axis, it was positive. Okay, so now you do the last one. So this time we're going from 0 to 10. So from 0 to 10, what would my two values be? -4 plus 10. Or oops, 8, sorry. And -4 plus 8, what's the result? 4. Now, overall, he went forward and backwards, but which way did he go more of if the result was positive? To the right. So you would say over t equals 0 to t equals 10 seconds, squirrel traveled a net of 4 units to the right. Okay, does anybody from science/physics remember what that's called? Oh, net unit of, thank you, 4. Put your 4 in there. Does anybody remember what that's called? It starts with a D. Displacement, very good. Okay, that's what displacement is. And we kind of barely covered that in the fall, but we're going to cover that a lot more today. So displacement is the net change in your position over a time period. So go ahead and turn to the next page and we'll do an example. Okay, so when you want displacement, you are going to take the integral of velocity from A to B. And that is going to tell you, I'm going to put here, the net change in position. Okay, so if you went positive and backwards the same amount, even though you moved, your displacement could be 0. Okay, now, distance traveled is different how? Okay, it's always what if it's distance? Always positive. So the way that I would make my integral always positive is I would put my v of t in absolute value bars. Okay, so distance is always positive, so you have to put absolute value bars around it. Okay? So let's see what that looks like on this next one. So take a look at it. It says a bug begins to crawl up a vertical wire at time 0. The velocity of the bug from 0 to 8 is given by the function, so this is v of t. And then it says that it's shown above, part A, when is the bug traveling to the left and the right? Now, quick point here. If he's on a vertical wire, this should be down, and this one should be up. Okay, you can't go left and right if you're on a vertical wire, right? That doesn't make sense. So fix it. Okay, how will I know when my bug is moving down based on his velocity? What sign would it have to have if my bug was traveling down? Negative. So for down, I need my velocity to be less than 0. And for my up, I need my velocity to be positive or greater than 0. So look on your graph. And also think about 2 less than would be below the x-axis, greater than would be above, right? So look at your graph. When is my graph below the x-axis to be traveling down? 6 to 8, very good. I'd put 6, 8 because v of t less than 0. Okay, now for up, what would I put? 0 to 6 because v of t greater than 0. Okay, and then in your mind, you should be thinking about if it's above or below. That's what we're looking for there. Okay, now part B, this is review as well. When does the bug change direction? Okay, look at your graph. At what time? 6. Okay, so t equals 6 because v of t changes sign. Now, I'm going to stop right there and look at the next part of the question. Next, it asks me if it's a max or a min. Okay, look at your graph. How did it change sign? From positive numbers to negative numbers or negative numbers to positive numbers? Positive to negative. So my slope went up and then down. Which one is it? Max. Very good. Okay, so v of t changes sign from positive to negative. Okay, and then I just circled max to be lazy. You can write it's a relative max if you want to. Okay, go down to part C. If I have velocity, how would I find acceleration? You remember? The slope. Very good. Remember, acceleration is the derivative of velocity, which means that in the graph, it's the slope of velocity. Okay? So acceleration is the derivative of velocity, which means in the graph, it would be the slope. So at 1, I'm here. Okay, I want at t equals 1, I want the slope. So when you have a line, you should count the slope from the endpoints. Okay, if you have Miss McDaniel, she always calls them pretty points. Okay, so pretty point here, pretty point here. What's the rise over run? Up 3 over 2. 3 over 2 is your slope. Okay, next let's find the acceleration at 3. Okay, so I'm going to put here behind this rise over run. Okay, a of 3. What's my slope at 3, which is here? 0, because why? It's a horizontal line. Very good. Okay, what about your last one? Next, I want a at 4. What happens at 4 in the graph? Okay, you'd say does not exist or undefined, but because what happens in the graph, there's a corner. So dne, because v has a corner at t equals 4, so v is not differentiable. Okay, remember the other word besides corner would be it could have a cusp, but one of the sides would have to be curved for it to count as a cusp. Okay? Alright, now we're in the new stuff. So the next one says, what is the displacement of the bug at 8 seconds? Displacement, do I use absolute value bars or not? No. So I'd integrate 0 to 8, v of t dt. And then using my graph, I'm going to find the area. So look at your top graph. I'm going to shade from 0 to 8. That'd be here to here. So 0 to 8, how many areas am I going to have to find? 2. You have a trapezoid on top. You have a triangle on bottom. Okay, so let's do the trapezoid first. So I do 1/2 base plus base times height. How long is my top base? 2. How long is my bottom base? 6. And then my height is 3. So 2 plus 6 is 8. 8 times 3 is 24. Cut it in half. This one is 12. Okay, then my little triangle on the bottom. 1/2 base times height. What's my base? 2. And my height is 1. 2 times 1 is 2. Cut it in half. The triangle is 1. Okay? So what will my displacement be? 12 plus 1? 12 minus 1. Good. Why minus? Because the 1 unit was below. That counts as a backwards. So he went 12 forward, then backwards 1. What's his net change? Positive 11. Good. Okay, now go to part D. This time I want distance traveled. What would I change in my integral? Still 0 to 8. Absolute value, velocity. Because remember that distance is not allowed to be negative. And then instead of 12 and negative 1, I'd use positive 12 and positive 1. And you would make each of those parts a positive value, which means my distance would be 13. Okay? Okay, go on to part E for me. It says the bug begins 3 inches above the bottom of the wire. So x of 0 is 3. Find the position of the bug at 8 seconds. Make a table for me. We're going to put time on the left, position on the right. Now, this is basically a candidate's chart. Okay, so at 0, what is the position? 3. Okay, what is my next critical number? Really, there's only one critical number. What was it? Where did it hit the x-axis? 6. From 0 to 6. Okay, look at the graph. How far did the bug go from 0 to 6? What was my area? 12. Which direction on the wire, up or down? If the area is above, he went up. So if he started at 3 and then he went up 12 units, where is he now? 15, good. Okay, now at 8 he stops, and at 8 he accumulated 1 unit, but where did he accumulate it? Down. So if he was at 15, but we know that he went down 1 because of the area being below, where does he end up at 8? 14. Very good. So it says find the position of the bug at 8 seconds. We would say x of 8 is positive 14, which means that he's 14 units above wherever the origin is. Okay? Last one, we already made our candidates table. What is the absolute minimum and the absolute maximum position? Let's do minimum first. What is it? Okay, the minimum position should be the position at 0, which is what? Minimum position is 3 at t equals 0. And then what is my absolute maximum position? My max position is 15 at 6. And then really if this had units, which it didn't, it would be good to include that. Okay? Alright, we're going to do one more like that, and then you should have about 15 minutes to finish your homework 3, which is the only homework that'll be due on Friday. Okay? Alright, turn the page. Okay, so it says a particle moves along the x-axis so that its velocity from 0 to 6 is given by a differentiable function whose graph is shown above. The areas of the regions bounded by the t-axis and the graph on 0 to 3, 3 to 5, and 5 to 6 are 8, 3, and 2. Label in your graph, this area is 8, this area is 3, this area is 2. So if they give you a non-geometric graph, they have to tell you how big each of those pockets are, or else you can't do the question to begin with. Okay, so part A, when is the particle at rest? What would I be looking for an at rest point? The zeros. Very good. How many zeros are there in the graph? 1, 2, 3. All of those count as at rest. So T equals 0, 3, 5. Okay, remember that if you want your particle to be at rest, you want its velocity to be 0. So we're looking for the x-intercepts. Okay, part B, we want a maximum position. Now, it doesn't say absolute, it says relative. So I'm looking for a sign change, which direction? Plus to minus or minus to plus? Okay, which one's a plus to minus change? 5. This one is a max. Okay, I'm going to label it relative max. Because V of t changes plus to minus. Okay, letter C. Find all values of time t where it has a relative minimum. Where's my relative minimum at? 3. Because V of t changes negative to positive. So all of this is kind of old stuff. Okay, now look at D. Write and evaluate an integral to represent the displacement of the particle from 0 to 6. Okay, where should my integral start? What time value? 0 till 6. And then if I want displacement, do I put bars or no? Displacement is no bars. Okay, what numbers would I be adding or subtracting? Give me all 3 numbers. What would my first number be? 8? Negative 8, good. Plus 3. And then plus 2 more? Minus 2, good. So that's negative 10 plus 3, which is negative 7. Overall, did the particle travel to the left or to the right? Okay, overall, its net change was to the left. Okay, look at E. This time I want an integral to represent the distance. What would I edit on my integral? Put absolute value bars. Now, don't put them around the whole integral. You need to put them specifically around V. Okay? And then instead of negative 8 plus 3 minus 2, I do positive 8 plus 3 plus 2. Because remember, regardless of which way your bug is traveling, he's traveling distance. So 8 plus 3 is 10, plus 3, or I'm sorry, 8 plus 2 is 10, 3 more is 13. Okay, letter F, find when the particle is farthest to the right. Did it say relative in there anywhere? Okay, then that means absolute. And if it's absolute, you need to do a what? Candidates chart. What goes in my chart? 2 things. Endpoints, right? So 0 and 6. And then what are my possible direction changes or critical numbers? 3 and 5. Very good. So this is my time. And I want to find the position at each one of these. Now, you can't look at the velocity graph to know the starting position. They have to tell you what it is. So go back and read the last sentence of your paragraph. Okay, look right here. What does it say? At time 0, the particle is at position -2. That's the first point that you would put in your table. Okay? Because without that point, you don't know where it starts to begin with. So I'm going to put this is in the question. And it has to be given to you somewhere, or else you can't do it. Okay, so from 0 to 3, look at your graph. How much area did we accumulate from 0 to 3? We accumulated 8 plus or minus. Okay, minus 8. So if I started at -2, but I went minus 8, where do I end up? -10, very good. That's my position at 3. Now, from 3 to 5, look back at your graph. From 3 to 5, I accumulated 3 more units, plus or minus those units. Which way? Plus. So I'm going to add 3. Negative 10 plus 3 is negative 7. Then until 6, thank you. Then until 6, which way is my guy going? My 2 units are below. So minus 2, so it'd be negative 9. Yes. 1 is not, but I can give it to him tomorrow. He's been absent for a while. I think he's sick. Okay, so when is it farthest to the left? What's my smallest position? Okay, oops, I skipped this one. Oh, well, we'll do this one first. So absolute min is negative 2 at t equals 0. And then right above it, I want farthest to the right. That's an absolute max. What would my absolute max have been? Oh, wait, hold on. Crap. That's not the absolute min. What's the absolute min for part G? Negative 10. And it occurs at 3. Okay, and then my absolute max would be negative 2, and it occurs at 0. Okay, last 3 parts are about speed versus velocity. For speed, what 2 things do you have to check? Acceleration and velocity. Good. So V of 2, A of 2. Okay, go up to your graph. V of 2 is going to be the y value at 2, because I'm looking at velocity. So at 2 in the graph, let me come up here. Here's 2. Is my y value at 2 positive or negative? Negative, because it's where? Below the x-axis. Very good. Okay, now A of 2 is referring to my slope. So for A of 2, look at your graph. How is your slope of your tangent line at that point? Going up or down? Up, which means it's positive. Okay, so I'm going to put positive slope here. So then down in my question, I would say, okay, I know V of 2 is negative because it was below the x-axis. I know A of 2 is positive because I saw a positive slope in the graph. Then overall, this one is less than 0, greater than 0. Is my speed increasing or decreasing? Decreasing because why? Opposite signs. Very good. Okay, so I'm going to put below here, positive slope here. So then I would say speed is decreasing because A of 2 and V of 2 have opposite signs. Okay, now go to letter J. Skip I for a second. If I want speed increasing or decreasing at 6, okay, look at your graph at 6. Is it above or below on your paper at 6?
I'll go with J.
Yeah, I'm skipping I and going to J, yes. So it's less than 0 because it's below. But what would acceleration be? Also negative because I have a negative slope. And if they're both negative, what's your speed doing? Increasing. Because V of 6 and A of 6 have same sign. Okay, last question. We skipped I for a second because it doesn't say speed. It only asks about velocity. Velocity will be increasing when acceleration is positive. Velocity will be decreasing when acceleration is negative. Now, think about why. Because acceleration is velocity's slope. So if I want velocity increasing, I want its slope acceleration to be positive. So you're not doing a double if it's asking about velocity increasing or decreasing. Okay, at 6, which way was my graph going? Up or down? Down. And if it's going down, then what's my velocity doing? Very good. Velocity is decreasing because v prime of 6, which is a of 6, is less than 0. And then I'm going to put, that's the slope of v of t. And remember that when you are using a graph, you should be saying what you looked at in the graph. So putting velocities, the slope of v of t is what you should put for that. Okay? All right, get out your homework 3, and I want you to just do the very last page. The back side is a question just like that. Okay? Yes? Yeah. Okay, so you're doing